this is a really big moment for Blue Origin. Can you tell me how NG-2 compares to NG-1?
Yeah, I think NG-1 was obviously our first mission. There was lots to learn, and we did learn a lot, and unbelievably successful in that we made our goal, which was to get to orbit. This time we're going to be a little bit more ambitious, and we want to not only get to orbit, but we have our first paying customer this time with ESCAPADE, and get them off to Mars. That's the first part of our goal, and then the second part of the goal is to land the booster out on Jacklyn.
Blue Origin's New Glenn finally came back for its second mission. And this time it wasn't just about reaching orbit. It was about proving it can come back. And riding on top, two small spacecraft that will try to answer one of Mars' biggest mysteries. How a once wetter world slowly turned into a frozen desert. For years, New Glenn existed mostly in renderings and conference slides. A huge, reusable rocket that always seemed to be 2 years away. NG-2 changed that. From Launch Complex 36 at Cape Canaveral, Blue Origin's heavy lift rocket thundered off the pad, carrying NASA's ESCAPADE mission. That's short for Escape and Plasma Acceleration and Dynamics Explorers. It's only the second New Glenn flight ever, but it already marks a turning point. This is no longer Jeff Bezos' answer to Falcon 9 on PowerPoint. It's flying real science for NASA. ESCAPADE is a heliophysics mission disguised as a Mars mission. Two almost identical spacecraft built by Rocket Lab will travel together to Mars and then slip into slightly different orbits around the planet. Their goal? To watch how the solar wind, a permanent million-mile-per-hour stream of charged particles from the Sun, slams into Mars and slowly strips away its atmosphere. Acting NASA Administrator Sean Duffy summed it up. Understanding Mars' changing magnetic environment helps explain how we turned from a more life-friendly world into the dry, cold planet we see today, and how solar eruptions still affect its surface today. If ESCAPADE works, it will fill in a key piece of the puzzle. How fast is Mars still losing atmosphere? And what does that mean for future human missions that will depend on that atmosphere for shielding and resources? For New Glenn, NG-2 was more than just a delivery job. After main engine cutoff and stage separation, the first stage headed back down towards the Atlantic. Far downrange, a converted ship named Jacklyn waited as a landing platform. While the booster fell back through the atmosphere, the upper stage lit its two BE-3U vacuum engines, pushing ESCAPADE into its Earth orbit, where the probe will later perform their own mass transfer burn. Back on Earth, all eyes were on the booster, and then touchdown at sea. New Glenn's first stage performed a safe return and landing. A capability Blue Origin absolutely must master if it wants to compete in the area of reusable heavy-lift rockets. But if you watch the landing footage, something probably caught your eye. It looked like it was touching down surprisingly far away from the middle of Jacklyn. Social media did what social media does. Speculation, criticism, and a lot of freeze-frame screenshots. Jeff Bezos stepped in to clarify. In a post on X, he explained that New Glenn's guidance system intentionally targets a point a few hundred feet away from the chip. The idea is simple. If the engine don't ignite on time or they throttle up too slowly, the rocket will hit the water instead of smashing directly into the landing platform. In other words, Blue Origin is flying with a big safety margin for now and plans to dial that conservatism back later once they have gathered more flight data. It looks sloppy, but it's actually a temporary safety feature. There was something else people noticed. Small flashes around the landing leads just after touchdown. At first glance, it looks like minor explosions on the deck, not exactly confidence-inspiring. But this part is actually engineering. Blue Origin uses a method described in a recent patent, sometimes called energetic welding. Instead of slowly bolting or clamping the booster to the deck, they use controlled explosive charges to instantly lock the legs to the platform structure. The shock force deforms and fuses metal in a very specific way, effectively welding the hardware together in a fraction of a second. Why? because a tall and narrow rocket sitting on a moving ship is inherently unstable. The faster you secure it, the safer it is. So, those flashes aren't the rocket breaking. They are the rocket being locked down. Taken together, NG-2 checks a lot of boxes for Blue Origin. A successful orbital mission for NASA, delivery of a science payload bound for Mars, a first-stage booster that flies, re-enters and lands at sea, validation of new operational tricks like energetic leg welding and conservative landing targeting. None of this means New Glenn is suddenly on par with Falcon 9 or Starship. SpaceX still has a decade-long head start and hundreds of successful landings in the logbook. But this flight does something arguably more important to Blue Origin. It proves that New Glenn is no longer just a delayed project. It's a working system starting to build flight heritage. And ESCAPADE ensures that New Glenn's early missions are not just demonstrations, but part of serious long-term science, understanding how the sun reshapes entire worlds.